All right, up and running. So this video is going to be about writing 7 different functions through the coordinates 5, 7, and 9, 10. And touchstone of growth in this discipline is seeing patterns. So I'm not going to talk at all. I'm just going to write the equations. I will mention what they are before I do them, and then you can think a little bit. So I hope we can see. Well, I guess I got to put this down. All right, so that's got a bunch of them here. Gonna do linear, quadratic, absolute value. And of course, there's the most important point on a curve. I've gotta use it. Absolute value, square root function. All right. Exponential growth function. Logarithm. Guess I don't want this here yet. And then a sinusoid, which can either be a sine or a cosine. I'll use sine function for that. I think it'll be easier. All right, so I said I wouldn't talk. After I get the marker in my hand, I'm not gonna. Just gonna write the equations and use the 3 patterns. All right, gonna use 5, 7. So it's 5, the first power plus 7, but necessary. 5 to 9, change to 4. 7 to 10, 3. So linear change to 4. Quadratic. X minus 5 squared plus 7. Quadratic change from 5 to 9 is 16. 7 to 10 still change from 5 to 3. Absolute value. X minus 5 plus 7. Absolute value change of 5 to 9, 4. Absolute value of 4 change. Get rid of that. 7 to 10, 3. That's that function. Now I can get you can still see the square root. So we got the square root of x minus 5 plus 7. We gotta get rid of square root change. Square root change. 5 to 9, because 4 goes there. 7 to 10, 3. And now we move along to exponential growth. Make sure you can see everything. All right, so we measure our y values first. We got 3. We got to get to 7, which is up 4. The next one's not going to be up 4. 3 to 10 is 7. And we got an x minus 5 over 4 again. Seen that before. And let's get the logarithm. And we're going to start with y equals. So I'll look at my first y, which is 7. I'm looking left to right. Could have done it right to left, but I'm looking left to right. 7 to 10 is 3. So logarithm. Asymptote of 2. So we're going to write x minus 2 using our first x. Gets us a change of 3. 5 minus 2 is 3. And our next one gets us 7/3, which becomes our base. And then the last one's a sinusoid. And I guess you can see everything. Try not to block anything. So we'll look at 7 and 10, but our most important y is the middle, which I didn't write yet, 17.5. Oh boy, I can't do this. 9, 10, 5, 7. Oh, terrible mistake. All right, gonna have to do the 5, 7 here. And the 9, 10, I had just done a video on sinusoids, so that was a Freudian or muscle memory mistake. 9, 10. We good now? Yeah, all right. So I guess I gotta still 17 halves. That's what's 8.5, right? It's between 7 and 10, so I can still get away with that. So 17 halves. And to get to 7, I actually have to. I'm gonna write this using 3 pi over 2. I'm gonna have to do. Didn't really want to do it that way, but I'm gonna do it. So 3 halves, sine function, both, and I got an x minus 5 plus 3 pi over 2. That's where I get my first minimum. And then I got 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 3.5 revolutions. And then it takes what, 4 units of time. All right, done. All right. Oh, I gotta push stop. Got to start the conversation somewhere.